Okay, so as I promised, I'm going to do a little recording here of some of the questions that we're still remaining from the homework. So we're going to look at number 55, where we were provided with a polynomial and a root or a factor, and then we're asked to find the other ones. So set down here, and 55, we have 6x to the third. It's 41. No, it's not. That was a plus, not a minus. Okay, and we're given that one of the factors is 2x. Okay, so since we know that this is a factor here, what I'm going to want to do is we're going to divide. This is a linear binomial, so I'm going to do synthetic division to reduce, because right now I can't factor this by grouping. Yes, it's a smaller polynomial, there's 4 terms, but it's still not something that's going to factor out nicely. You can try, but you're going to see that it's not going to work. So I'm going to do synthetic division, because it's a linear binomial, I'm going to divide by. So 6, 1, negative 9, negative 14. So as I said in class earlier today, I am always checking first that this is in order. Okay, there's no terms missing, so I don't have to put any placeholder zeros. And then the number that's going to go in the box is going to be negative 1/2. Because again, we solve for when that's going to be 0. That's what goes in the box. So now we'll go ahead and divide. So 6, 3, is going to be 8 divided by 2. So that's going to be 19. Negative 19. So this is going to be negative 8, and that divided by 2 will be a positive 14, which gives me a remainder of 0. Okay, perfect. So this is making sense with what I was already told in the problem, that this is a factor. Okay, now I have left over this. Okay, so what is that as a polynomial? Well, this is telling me 6x squared plus 38x minus 20. So is this factorable? Well, first off, there's a greatest common factor here that I could take out, and that is 2. So I'm going to factor out a 2. And now I'm going to see if maybe that is something that I can more easily factor. So 38 divided by 2, so that's going to be 19. 28 divided by 2, that's all right, so now, can I factor this? Well, let's try. Maybe it doesn't, but at least it's a quadratic. I could use quadratic formula if I find out I can't factor it. But at least I was able to pull out a 2 from it. So now, okay, 3, 1. So 14 is 7 and 2. So I could put the 7 and the 2 here. So that's going to give me 21 and 2. Well, that can give me 19 if I make the 21 positive and the 2 negative. So that now falls in agreement with the rest of the polynomial. I'm going to get a negative 14. These outer and inner terms will add up to be that 19 in the middle. So there we go. So there's the remaining factorization. So going back up here to the top, okay, I'm going to write 3x minus 2, and then x plus 7. Now, here's what's going to happen with this 2, okay? And we talked about this, about the differences between if I did this using long division versus synthetic division. When you are doing synthetic division and it has that coefficient in the front, when you put that number in the box, this is a fraction, what happened? Oh, that factor of 2, that's what happened here. So it's not the division, you can kind of think of it this way. The division doesn't see this as 2x minus 1. It sees it as x plus 1/2. That's why that 2 is out here. So according to the synthetic division, it's looking at it like this. So that's why up here, I'll put a box around this. I'm gonna write it like this. Notice, so when you look at this, you're like, but wait, what happens to that 2? Did we forget about the 2? No, the 2's already in here. It's just that when we do the synthetic division, it's factoring it out. So, just something again to be careful about, and I mentioned about the differences between synthetic division and long division. So if you want to avoid having to necessarily think about that, or if you find that confusing to deal with, whenever then you're dividing by something that doesn't start with a 1, like if it looked like this, it would be beautiful. But if it looks like something like this that you have to divide, then maybe you want to divide is by long division, because then the long division isn't going to cause issues like this. But I just want you to understand it's not that it's wrong, or it's not like we forgot anything. It's just the way that the synthetic division works of having to go through that process of solving to get the number that goes in the box, and then how the factoring is going to then change a little bit in appearance. But this would be my full factorization. So my roots would be x equals -1/2, +2/3, and -7. So those are my 3 answers for this polynomial, and we know there's supposed to be 3 because the power is 3. So that's number 55. All right, now moving on, let's look at number 60. We had to make a list of all the possible rational zeros and then find all the rational zeros. So much like what we did earlier today, we're going to start from scratch with this one. So in number 60, we have 4x to the 5th. So 4x to the 5th minus 8x to the 4th minus 5x cubed plus 10x squared plus x minus. So there's my polynomial. Okay, so it tells us we have to do the list. Okay, so let's go ahead and do the list. Again, before I start making my list, I want to make sure everything is in order. So yes, it's going in descending order, all good. So my rational roots test is going to be the factors of 2 over the factors of 4. Okay, there we go. All right, factors of 2, that's 1 and 2. Factors of 4, 1, 2, and 4. So my list is 1, 2, 1/2, 2 halves, which is 1. We already have that on the list. And then 1/4, 2/4, which is 1/2, already on my list. So short list. So now, which ones work? Okay, so here's where we can graph to kind of narrow down which one of these would work. I'm going to do this as if you were just asking me to find the roots. So as I showed you today, the next thing that I would do to maybe help me reduce the work I need to do, I'm going to do Descartes' rule of signs. So I see right now, as it's a positive x, how many sign changes? So we have 1, it went from plus to minus, so 1, no change, still negative. Change now again, so there's 2. Stays positive, no change. And then finally, a negative at the end. So a total of 3 positive real roots, or there are 1 positive. So 1 positive real root. So one of those two things. So at the bare minimum, there is going to exist a positive real answer. Okay, so there's no way that I'm going to say all the answers to this polynomial, all the zeros, are negative, or they're all imaginary. There's at least one positive real answer. All right, now let's look at the negative side of this. So I'm right above here. Let me actually use a different color. So now I'm going to look at the negative function. So I'm going to say f of negative x. And again, remember the shortcut. It's an odd power. Those things are going to switch. So this is positive. It's an odd power. So it's going to make that negative. This is going to stay negative. It's an even power. This is an odd power. It's negative, so it's going positive. Positive. This is odd, negative, and then that. So in blue are my signs for the negative version of this polynomial. So again, I'm going to go through and count the sign changes. So negative to negative, so no sign changes yet. There's a sign change. We went from negative to positive. Still no sign change, still positive. We switched again. There's the negative. And then we don't switch. So in total, 2 sign changes. So that means 2 negative real roots, or there may be no negative. So we have 2 possibilities here. So again, here's why I like to do this first, because for sure a positive one has to exist, but there could possibly be no negative ones that exist. So where should I really try first? Let's try the positive ones, because I don't want to have to go through all my negatives to end up with nothing. At least with the positives, I'm probably going to walk away with something. I have to. So I'm going to start with positive 1. So again, I go using the numbers on my list. I'm not just pulling numbers out of anywhere. It's these numbers in particular. So I'm going to start with positive 1. And we're going to go one by one, doing synthetic division to see which one works. So we're going to go, so 4, negative 8, negative 5, and 1, negative. Those are my coefficients. All right, so let's go through one at a time. So 4, negative 4, negative 4, 9, 1, 2. Hey, it works. So positive 1, boom, boom, it works. So I'm going to start over here. I'm going to write roots that I got. I already got 1 works. Great. Now, as I did show you today, we might have a multiplicity happening here. So here's where, if you make a graph of this in your calculator on Desmos, looking at the behavior of the graph, because if it has an even multiplicity, meaning it shows up more than once, I should see a bounce off the x-axis, not go through the x-axis. So I'm going to try again. Maybe that positive 1 works again, because right now this polynomial that I have left, I can't factor that. That's still too big. Let me try again to try to make this smaller. So I'm going to try 1 again. If 1 doesn't work, then that's it. 1 will never work anymore. It just worked the first time. But if it worked before, it might work again. So that's why I always like to start off with the ones that have worked. That way, if it doesn't work anymore, I don't have to keep trying it over and over again. So now let's go here. So 4, I got a 0, 0, negative 9, 8. And this isn't going to work. We're going to get not a remainder of 0. So 1 doesn't work anymore. It worked one time, but it doesn't work anymore. So I know for sure it's a multiplicity of 1. That root. Okay. So, all right, let's try negative 1. Because remember, now what could happen? I could have some negative roots. They show up in, there's 2 of them. So let's try negative 1. Okay, so now I'm going to go here. And so 4, negative 4, so that's negative 8. Positive 8, so that's a negative 1. Then we have positive 1, which is a 2. And then negative 2. All right, so we got an answer. Negative 1 is one of my other roots. So now I'm left with this as my polynomial. Okay, so now this as a polynomial, let's write this out. So this is 4x cubed minus 8x squared plus, oh sorry, not plus, minus x plus 2. All right, so I now have this. After 2 divisions, I now have this. This is now something, okay, I could attempt to factor this. Maybe it might work. So I'm going to do factoring by grouping. So I can factor out a 2x squared from the first group. That leaves me with 2x minus, sorry, not 2x. Sorry, not a 2, I meant a 4. So that would leave me with x minus 2. Okay. Then from the first group, I can factor out is a 1, a negative 1, which will also give me an x minus 2. So factoring by grouping, successful. I was able to factor this. So now this is really saying 4x squared minus 1 times x minus 2. So you can see, oh, what's the other, one of the other roots? 2. I'm going to come over here, add that to my list. So 2. So how many positive roots do I already have at this point? Oh, I got 2. So it definitely is not going to be this anymore. It has to be this. That means there's another positive answer that remains. Okay. Also, how many negative roots do I have? 1. So for sure, it can't be this. That means I need to find another negative root. So there's one more positive root remaining because I got 2. I would need 3. And there's one more negative root remaining because I'm supposed to have 2 and I only found 1. So now this one here, this is the other part that can still be factored because it's a difference of squares. These are 2 perfect squares here. So we can factor this one more time. So ultimately, this would factor out to be 2x minus 1, 2x plus 1, x minus 2. So here are the other 2 roots, positive 1/2 and negative 1/2. So there we go. And now that makes sense with what we had said based on Descartes' rule of signs. I got 3 positive roots and 2 negative real roots for a total of 5 answers. Okay. Now, if I had to write the prime factorization, which it didn't, or the factorization of the polynomial, what would I have written down? It would have been x minus 1, x plus 1, x minus 2, and 2x plus 1, 2x minus 1. That would have been the prime, or not the prime factorization, but the polynomial factorization of this one in particular. Okay. All right. So let's now look at the next one. Space here. Okay, so now let's look at 61 and 62. where we just had to do Descartes' rule of signs. We're not asked to find any roots, we're just asked to write out the possibilities. So in 61, we have 2x to the fourth minus x cubed plus 6x squared minus x plus 5. So when we do Descartes' rule of signs, which we've already done a couple of times already in the examples we did today, this number 61, we start with the positive one to see what are our possibilities for positive roots. So I just count the sign change. Again, before I start counting the sign changes, make sure it's in order. So I do say yes, everything is in order. It's going from biggest to smallest. Good. Now I'm just going to count the sign changes. So plus, minus, so there's 1. Minus to plus, there's another. Plus to minus, there's another. And minus to plus, there's another. So in total, we ended up with 4 positive real roots. Or 2 positive real roots. Or no positive real roots. So these are all the possibilities when it comes to talking about positive real roots. Remember, we always reduce by 2's because answers could be showing up in pairs, meaning I could have non-real answers, and if they're imaginary, they don't show up by themselves. They show up always in pairs. That's why I subtract by 2 until I get to 0. Doesn't make sense to keep subtracting after that point, because the lowest amount we can have is there are no roots. I can't say there are -5 roots. For counting, the smallest we can get to is 0. All right, so that's for my positives. What about my negative possibilities? So for your negative possibilities, again, we're going to want to look at the negative polynomial. So if I were to plug in -x instead of +x, how would the signs change, and then counting those sign changes? So again, the shortcut I gave you was if it's an even power, leave it alone. If it's an odd power, then you're going to want to change the sign. So this is plus right now. It's an even power. It stays. This is an odd power. It's negative. It's going to change to a plus. This is an even power. It's plus. Stays. This is an odd power. It's negative. It changes to plus. And the constant always is just as is, because there's no x there. So if I look on the negative side, there were no sign changes. It just stayed positive all the way through. So that means there are no negative real roots. So if I were asked to solve, and I go and I do my rational roots list for this, I would definitely not use any negative numbers, because I know for sure, there's no other possibility, it has to be for sure, there are no negative answers. If there's answers, they're either going to be all positive or a mix of positives and imaginary, but there are no negative answers. So that's the strength to this, is that it allows you to get rid of some possibilities. Okay, and also to check our answers when we get to the end of, do I have the right combination of answers? Does it make sense with Descartes' rule of signs? Okay, so now let's go ahead and do 62, which is the same thing. We're just going to change the polynomial. Erase this. Okay, and I'm going to keep this here because we're probably going to write stuff with positives and negatives. All right, so let's look at 62. So 62, we have 3x to the fourth plus 5x to the third. Minus 6x squared plus 8x. minus 3. All right, so let's count sign changes. So positive. So it's positive now. Stays positive, so nothing yet. Goes negative, there's 1. Goes back to being positive, there's 2. And then goes back to being negative again, there's 2. So total 3 sign changes. So 3 positive real roots. Or there is 1 positive real root. So again, when I'm reading this, what is this telling me? Well, for sure, there's got to be at least 1 positive real answer. So it's not like in the last one where it was like, there's no way there could be a negative answer. Here, this is telling you guaranteed there's at least 1. Maybe there's more. There could be 3, but at least there's 1. So it's not like you don't try any of the positives. You're going to try them. And if you find 1, okay, well, maybe that's the only one, but there might be 3 more. All right, let's go ahead and look at the negative version of this. So again, if it's an even power, we leave it alone. So this is positive now, it stays positive. This is positive now, but it's odd, which is this is negative, it's an even power, it stays the same. Positive, odd, which is negative there for that constant. So sign changes. I see 1, and then after that, doesn't change after that point. So 1 sign change on our negative polynomial. So that means there is 1 negative. So again, only 1 possibility. So for sure, if I have my list again of possibilities from the rational roots theorem, for sure, there has to be 1 negative answer. So it's not like, oh, I have no negative answers. There's got to be 1. And only 1. Not like, oh, I have 3 answers that are negative. I already know you did it wrong. Why? Because that can't happen. There's only this possibility. So out of the 4 answers total, I already know 1 of them is negative, and it's a real number. The other 3 that are left, maybe they're all positive, or maybe 2 of them are imaginary, and 1 of them is positive. But for sure, I already know 1 of your answers is a negative real number. All right, so that does it for our questions from this assignment. So if you found this useful, please make sure to hit the like button on the video and subscribe to the channel, and I will see you guys on the next video.